All right, welcome to part 2. Let's continue on. Figure 4, starting to read here. Figure 4 compares the electron dot diagrams of elements in period 2 and 3. Let's check out figure 4. It's on your next page right here. Figure 4, it compares the electron dot diagrams of periods 2 and 3. Mr. Worley, what is periods 2 and 3? All right, let's check out our periodic table, and you'll find out. Here we go. Look, here's period 2, dun dun dun, and here's period 3, dun dun dun. Da 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 da, period 2, da 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 da, period 3. Okay. So, oh, my lines are still on there. Now, notice that each element has one more valence electron than the elements to its left. For example, group 1 elements have 1 valence electron. The elements in group 2 have 2. Elements in group 13 have 3 valence electrons. Elements in group 14 have 4, and so on. Elements in groups 3 to 12 follow a slightly different pattern. The elements within a group have similar properties because they all have the same number of valence electrons. Ding, 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 ding. Did you catch that? Last chapter we learned that elements in a group have similar properties, and here's why. They all have the same number of valence electrons. Valence electrons are what are responsible for chemical reactions. Oh, totally cool. Science rocks. All right, let's keep moving. Noble gases. The group 18 elements are the noble gases. Atoms of these elements have 8 valence electrons, except for helium, which has 2. As you have read, atoms with 8 valence electrons, or 2 in the case of helium, are stable. Such atoms are unlikely to transfer electrons to other atoms or to share electrons with other atoms. As a result, noble gases do not react easily with other elements. Even so, chemists have been able to make noble gases form compounds with a few other elements. How do they do that? They blast them with lasers, energy, and very crazy things, but that's for later. Reactivity of nonmetals and metals. Reactive nonmetals and metals. Now, look at the elements in the column just left of the noble gases. Hey, let's check that out on our periodic table. Just left of the noble gases are right here. Ja-ja! What were those? Those were called the halogens. The group 17 elements, the halogens, have atoms with 7 valence electrons. A gain of just 1 more electron gives these atoms the stable number of 8 electrons, just like a noble gas. As a result, the halogens react easily with other elements whose atoms can give up or share electrons. At the far left side of the periodic table is group 1, the alkali metal families. You check it out yourself. Group 1. Atoms of the alkali metal families have only 1 valence electrons, except for lithium. Except for lithium, the next lowest energy level has a stable set of 8 electrons. Wait a minute, Mr. Worley, slow down. Check this out. What it just said is, except for lithium. Let me read that again. Here, look at the periodic table. Except for lithium, the next lowest energy level has a stable set of 8 electrons. What is it saying? Okay, let's say here's potassium. The next lowest energy level 3, has energy level 3 has a full set of valence electrons for calcium. What about for rubidium right here? Well, the next lowest energy level for rubidium is energy level 4, period 4, and it has a total of 8 valence electrons. Remember, we skip the middle. So, let's keep reading. Back to our book. Oh, those funny lines. Now, gotta keep reading. Therefore, alkali metal atoms can become chemically more stable by losing their own valence electrons. This property makes the alkali metals very reactive. Next page. Why don't you take a break? Why don't you put me on pause and write down a few notes of what we've just learned about. We've learned about halogens gaining an electron to become more like noble gases. We've learned that alkali metals lose an electron to become more like noble gases. All right. Pause. Welcome back. Other metals. Look at the elements in group 2 through group 12 of the periodic table. Like the group 1 elements, These elements are metals. Most have 1, 2, or 3 valence electrons. They react by losing these electrons, especially when they combine with oxygen and other halogens. So what it's saying here in the periodic table is group 2 through 12. So group 2 through 12, this area right here, da-da-da-da, and including group 2. Ah! All have either 2 or 3 valence electrons, and they react, how did it say? They react by losing these electrons, especially when they combine with oxygen. So all of these want to lose their electrons to get closer to the noble gas 8. All right, let's keep reading. How reactive a metal is depends on how easily its atom loses valence electrons. Some metals, such as those in group 2, the alkaline earth metals, lose electrons easily and are almost as reactive as the alkali metals in group 1. Other metals, such as platinum, PT, in group 10, and gold in group 11, are unreactive. In general, the reactivity of metals decreases from the left to right across the period. Yeah. In general, the reactivity of metals decreases from left to right across the periodic table among groups 1 and 2. Reactivity increases from top to bottom. That sounds like a great quiz question. You might want to put that in your notes. Yeah. All right, let's keep the reading alive. Other nonmetals. Elements in the green section of the periodic table are the nonmetals. Notice that unlike the metals, most nonmetals are gases at room temperature. 5 nonmetals are solid. 1 is a liquid. All of the nonmetals have 4 or more valence electrons. Like the halogens, oh wait, whoa, look at that. All of nonmetals have 4 or more valence electrons, yeah. Like the halogens, other nonmetals become stable when they gain or share enough electrons to have a set of 8 valence electrons. Nonmetals combine with metals usually by gaining electrons, but nonmetals can also combine with other nonmetals by sharing electrons. Of the nonmetals, oxygen and the halogens are highly reactive. In fact, fluorine is the most reactive element known. It even forms compounds with some noble gases. Wow! Fluorine is so hungry for that extra electron, it'll steal one from a noble gas. Wow! Let's keep the reading alive. Go to the next page. And here we go, we're finishing up. Metalloids. Metalloids, look at your periodic table. Where are the metalloids? Metalloids, where are you? They're kind of in this area. You can find them on your periodic table very easily. Metalloids. Several elements known as metalloids lie along the zigzag line between the metal and nonmetals. The metalloids have from 3 to 6 valence electrons. They can either lose or share electrons when they combine with other elements. So, depending on the conditions, these elements can behave as either metals or nonmetals. Wow, cool. Hydrogen. Notice that the hydrogen is located above group 1 in the periodic table. It is placed there because it has only 1 valence electron. However, hydrogen is considered to be a nonmetal. It is a reactive element, but its properties differ greatly from those of the alkali metals. All right, class, that concludes our reading section for today. Remember, your assignment is to answer in the book these questions here. Don't have your book? Well, put the video on pause and read them and answer them on your paper. Didn't get it? Didn't feel like it made sense to you? Watch the video again, stopping every section and going over it in your head until you get it. Read along. Come to class tomorrow with questions that you didn't get, because we won't have a lot of time for question and answer before the quiz. So, study well now, do well tomorrow. I'm proud of you, class. Thank you for watching the video, and I look forward to our learning experience next class period. All right, peace out. Keep the reading alive. Bye-bye. Oh, God loves you.